Humans see with eyes and our brain processes all that information. It's pretty cool, right? We spot a cat crossing the street, another car approaching, or a kid running towards a ball. Our brain figures it all out super fast, almost instantly. But how does a car, a complex machine, manage to do something similar? Does it have eyes? Well, kind of. But these eyes are way different from ours, and much more powerful in some ways. These cars need to see absolutely everything, all at once, even when it's pitch dark outside. That's a really tall order, a huge challenge. So, they need some seriously awesome technology to pull it off successfully. It's not magic, folks, it's pure, unadulterated science and engineering. Now, imagine you're tasked with building one of these incredible self-driving cars. You definitely can't just stick a pair of simple eyeballs on the hood and expect it to work. Nope, not a chance. We need something far more robust, something much more powerful and reliable. We need sensors, and not just one or two, but lots of them, all working together. Think of it like giving the car a set of amazing superpowers. X-ray vision? Well, almost with some sensors. The ability to see in a complete 360-degree circle? You betcha. These sensors are the car's crucial window to the world, constantly feeding it a massive stream of information every single second. It's a veritable data explosion. So, what exactly are these cars looking for with all their fancy sensors? The answer is everything. They're constantly scanning for other cars on the road, people walking on sidewalks, and cyclists zipping by in bike lanes. They need to clearly see traffic lights and understand their colors, read road signs accurately, and even detect those pesky potholes that can ruin your day. Even something as small as a plastic bag blowing across the road matters and needs to be identified. A human driver might miss some of these small details sometimes, especially if they're feeling tired or get distracted. But a self-driving car? It's always on high alert, always scanning its environment. It's like having a super attentive co-pilot that never blinks and literally has eyes in the back of its head. The big overarching goal here is to create a super detailed, constantly updating digital map of absolutely everything that's happening around the car. It's not just about seeing things in a passive way, it's about truly understanding the environment. Where is that other car going? How fast is it moving? Is that person standing by the curb about to step into the street? These are critical questions that the car's powerful onboard brain needs to answer correctly every single millisecond. It's a massive computational challenge, a really tough nut to crack, but that's precisely what makes it so incredibly exciting for engineers and scientists to figure out. This is engineering at its absolute coolest. First up in our sensor toolkit, let's talk about LiDAR. That rather technical-sounding name stands for light detection and ranging. Sounds pretty fancy, doesn't it? And believe me, it is. Imagine a sophisticated sensor, often seen spinning rapidly on top of the car, shooting out millions upon millions of tiny invisible laser beams every second. These laser beams travel outwards and then bounce off everything around them, other cars, tall trees, nearby buildings, pedestrians, you name it. By precisely measuring how long it takes for each beam of light to return to the sensor, LiDAR creates an incredibly detailed and accurate three-dimensional map of the car's surroundings. It's like painting the entire world with countless invisible light points. Super precise stuff indeed. Then we have radar, another crucial sensor in our self-driving car's arsenal. This isn't brand new technology. We've actually used radar for planes, ships, and weather forecasting for many decades. But on a car, it's a total game changer. Radar systems work by sending out radio waves. These radio waves are particularly awesome because they can effectively see through stuff that cameras and sometimes even LiDAR can't penetrate. Think about driving in heavy rain, thick fog, or even a blinding snowstorm. Radar cuts right through those conditions like a hot knife through butter. It's also exceptionally good at telling how fast something is moving towards or away from the car, and exactly how far away it is. Is that truck up ahead suddenly slowing down? Radar knows instantly. And of course, we absolutely have to talk about cameras. These are a bit like our own human eyes, but often much more powerful and versatile. They see the world in full color, which is super important for distinguishing things like traffic lights. Red means stop, green means go. Cameras get that critical information. They can also read road signs, detect painted lane markings on the pavement, and identify pedestrians, cyclists, and animals. Many self-driving cars have multiple cameras, strategically placed around the vehicle, giving them a wide, comprehensive field of view. They capture the rich visual detail that helps the car truly understand the context of its complex surroundings. So, to sum it up, you've got LiDAR for creating that detailed three-dimensional map, radar for performing reliably in bad weather conditions and detecting speed, and cameras for seeing in color and capturing fine details. Each one of these sensors is a superstar performer in its own right, a marvel of technology. But here's the real kicker, the secret sauce. None of them work in isolation. They are designed to be a team. Usually you'll find these sensors strategically positioned all over the car. Some are mounted on the roof for an unobstructed bird's-eye view. Others are integrated into the grille, on the sides and at the back. They all work together in concert, constantly feeding a torrent of information to the car's central brain. It's this powerful combination, this sensor fusion, that gives the car its amazing and reliable vision. Okay, so the car now has all this incredible data pouring in from its LiDAR, radar and camera systems. That's a massive amount of information arriving every fraction of a second. What happens next? It's like having a zillion different puzzle pieces dumped in front of you. The car's computer, which is essentially its brain, has the incredibly complex job of putting them all together to form a coherent picture. This sophisticated process is called sensor fusion. It's super clever and absolutely vital. The brain cross-references the information from different sensors. For example, if the camera sees a person and LiDAR simultaneously confirms an object of human-like shape and size at that exact spot, the car becomes much more confident in its assessment. This makes the entire system incredibly robust and helps it avoid critical mistakes. But wait a minute, how does the car even know what a person or a stop sign or a bicycle looks like in the first place? It learns. This is where the magic of machine learning and artificial intelligence, or AI, comes into play. It's truly awesome stuff. Engineers feed these advanced AI systems massive, colossal amounts of data. We're talking about millions upon millions of images of stop signs from every conceivable angle and in all lighting conditions. They also feed it thousands of hours of video footage showing pedestrians crossing streets, cars turning, and cyclists navigating traffic. The computer tirelessly chews through all this data, meticulously looking for patterns and learning to distinguish different objects. It's like teaching a very, very smart kid, but on a vastly accelerated and massive scale. Through this intensive learning process, the car doesn't just learn to recognize static objects, it also learns the fundamental rules of driving and typical road behaviors. It learns that red lights mean stop, and green lights mean go. It learns how to merge smoothly and safely onto a busy highway. It learns how to navigate a complex and often chaotic busy roundabout. It even starts to learn some of the unwritten rules of the road, like how other human drivers might behave in certain common situations. It's constantly refining its understanding of the world, getting incrementally better, smarter, and safer with every single mile it drives, whether those miles are in the real world or in highly realistic computer simulations. All this meticulously collected data, gathered from countless hours of real-world driving tests on public roads and even more hours spent in sophisticated virtual simulations, forms a giant, ever-expanding library of experiences. This enormous dataset is often referred to as big data. The more data the car processes and learns from, the smarter and more capable its driving algorithms become. It's like building up a massive, detailed memory of almost every possible road scenario it might ever encounter. This vast knowledge base helps the car to anticipate what might happen next on the road. It's not just reacting to events as they unfold, it's actively trying to predict them. That's a huge and critical step towards achieving truly intelligent and safe autonomous driving. It's an ongoing, iterative process of testing, learning, and continuous improvement. So, how does driving in a robot car actually compare to us humans when we're behind the wheel? Well, these autonomous cars have some truly amazing strengths that we simply can't match. They have complete 360-degree vision, seeing in all directions simultaneously all the time. They don't get tired or fatigued on long road trips, unlike human drivers. They don't get distracted by a text message or a particularly cool song playing on the radio. Their reaction times to sudden events can often be significantly faster than ours. These are all big pluses, especially when it comes to road safety. Imagine a world with far fewer accidents, perhaps even eliminating most of them, because the driver is always paying perfect attention. That's the ultimate goal here. But let's be fair, humans are still pretty amazing drivers, especially when faced with really weird or unexpected situations. That sudden, unannounced road closure with a complicated detour, that flock of geese suddenly deciding it's a good time to leisurely cross a busy highway, or a police officer manually directing traffic at an intersection where the lights are out. We humans can usually figure out these novel and confusing situations by using our common sense, intuition, and broader understanding of how the world works. Current robot cars are getting better and smarter every day, but these kinds of complex, unpredictable scenarios are still a huge challenge for them. It's something that engineers and researchers are working on incredibly hard to solve. The future with self-driving cars integrated into our daily lives looks pretty exciting, doesn't it? Just take a moment to think about the possibilities. Commutes could transform from stressful ordeals into productive work time. Or perhaps they could become relaxing downtime, a chance to read a book or watch a movie. People who can't drive today, like some elderly folks or people with certain disabilities, could gain a whole new level of freedom and independence in their mobility. Our cities might even change in profound ways. If cars can efficiently drop you off at your destination and then go park themselves, or, even better, go pick up someone else who needs a ride, maybe we won't need so many giant space-consuming parking lots in our downtown areas, more space for parks and green areas perhaps. Of course, we're not going to arrive at this future overnight. It's a journey, not a sprint. There are still big, important questions to answer about overall safety, cybersecurity, and even the ethical dilemmas these cars might face. How safe is considered safe enough for widespread deployment? Who is legally responsible if an autonomous car is involved in an accident? We need clear, comprehensive rules and regulations, and we definitely need lots more rigorous testing in all sorts of conditions. But the potential benefits are truly massive and transformative. Safer roads for everyone, more accessible transportation options for more people, and maybe even a greener planet if these vehicles help us use our transportation resources more efficiently. It's a journey of innovation, and we're building this amazing future one sensor, one line of code at a time. It's going to be an awesome ride. If you like this video, make sure to subscribe to the channel and like and share the video.